And this is the outcome of our ICP algorithm. It generates the ICP wall transform.txt. So open this, and here's the result. As you see, the trajectory of our robot is much smoother than the previous result. And as we step through the robot's positions, we see now that by using the ICP, those scan points that were turned in the last result very strongly are now matched to the walls. So interestingly, this solution gives us a globally correct as well as a pretty smooth trajectory, where of course the smoothness is related to the fact that we are now using much more points to determine the transformation, which means that any noise that we have on a single point measurement does not influence the final solution of the transformation as much as in the case of our cylinders, where we had only a maximum of 6 points that were used to determine the transformation. And if we compare this now to the reference trajectory, we see our solution is now pretty good. It is globally good and it is also pretty smooth. So congratulations, if you made it that far, then you can be really proud of yourself because you developed a lot of useful algorithms during this unit B. So what we covered was we used sensor data to improve the robot's pose, so far without having a rigorous error model. So we explored two techniques. The first was a feature-based localization. And what we did here was first the assignment of landmarks, which in our case were cylinders, then the direct solution of the similarity transform, and we dived into mathematics a bit there. And finally the correction of the robot's pose using the transform we obtained from matching the landmarks. Then the second part, we explored featureless localization by matching scan points to the walls of the robot's arena. So the first step was to assign the points to the walls of the arena, and in the second part we learned about the ICP to find the optimal transformation in an iterative fashion. And now in this unit you not only learned those fundamental localization techniques, but you also implemented two very useful algorithms, namely the direct solution of the similarity transform, which does not require any start values or any iteration, and the iterative closest point algorithm. So this is it for Unit B, and hope to see you in the next unit.